Hi, well, welcome back. I have another application problem with rational functions. This is one that's on my take-home test and other questions I give in my class. But what we have here is a question on liters. Okay, you have a 1,000-liter tank contains 50 liters of a 25% brine solution. You add X liters of 75% brine solution to the tank. The concentration C is given by the proportion of the brine in the total solution, and the final mixture is given by this equation right here. Okay, so they give you the equation. Many times you maybe sometimes asked to find it. You don't necessarily have to, but this is what we got here. All right, and we're going to be asked how to determine some different parts of this. So right here, the first question they ask us to do is determine the domain. Now, domain is what you can plug in for, in this case, X. And X is the liters of 75% brine solution in the tank. So 75% brine solution in the tank. Now, things you have to understand are the constraints of the problem. So think about the problem. So the physical constraints of the problem that they give you. All right. First off, what could be plugged in here? So if you have a 1,000-liter tank, contains 50 liters of the 25% of brine solution, and you add X liters of the 75% solution. So the question is, what can you add to the mixture? Well, for example, can you add a negative value, any negative values? So given X, can you have any negative values? The answer would be no. All right, you can't add a negative amount of brine solution to this mixture. So can you add a 0 to this mixture? In actuality, yeah, you could. We don't have to add anything to this mixture, so 0 would be a viable option. It would be equal to 0. So this means that we can add no. All right, this means when we put the 0 here, that means that there is no, all right, or 75% brine solution added. Okay, which is possible. All right, which is possible. Now, the other thing is, how much can you add? Well, we do have physical constraints. It says there is only a 1,000-liter tank, and we already added 50 liters of this 25% solution. So that means if you just take 1,000, all right, 1,000 minus 50, all right, what you get is 950. 950. All right, and right here we have to use that value, and that value is actually going to equal our other constraint. That's actually going to equal 950. So right here, we know that the most we can add of the 75% solution, 75% solution is 950. So that means X has to be less than. And can it equal 950? Yes, it can, because if you put in 950, you would have 1,000 in the tank. And so we have that as our answer. Okay, so right there, all right, I'll get rid of this. All right, we got this 950 because this is the total amount of the tank. All right, total tank. And then right here, this is the 50 liters of the 25% solution. 25% solution. And then we get the total, all right, possible, or max possible. All right, possible for, all right, the 75% of brine. Okay, or brine. All right, so that's our domain. All right, 0 to 950. That makes sense. That's pretty easy. Now, next thing is, as the thing is filled, what happens to the rate at which the concentration of brine is increasing? So, as you keep on adding, you try to figure out what is the concentration of brine, all right, as it increases. So, as the thing is filled, what happens to the rate at which the concentration of brine is increasing? So, if we look at this, one thing it would be nice if we just look at our calculator, we can kind of graph this to see what it looks like. So, as this gets larger and larger, so we're going to actually go over here, and I'm going to go to Windows. I actually punch this in right away. Oops, y equals. All right, and I punched in the equation in my calculator, my graphic calculator. And what we're going to do now is we're going to go to our window. We're going to change this up. We're going to go. We have a standard window, so we're going to change. We're going to say, well, we start at 0, and we can go up to 950. But I'm going to go to so the most you can have is 950. So I'll just go to 950. All right, and we'll go by tens. Okay, so each one's going to be 10. We'll have negative 10 to 10. All right, just give us a little dimensions. We'll see how that looks, and we'll graph this right here. See how this looks right here. So we can see this. It keeps on going higher and higher. All right, now what do you notice is happening? As we get to 950, you see something. I'm going to bring this graph over here so you can write on it. Okay. So as you look at this graph right here, and as we answer this question, as the tank is filled, so the tank is filled, all right, so this is basically our x values. The y values, all right, is going to be, what is the y value? Y is the proportion of brine to the total solution. So the proportion of brine to the total solution. So the proportion of brine, okay? Proportion meaning percent, okay? So this is the percent of brine in the solution. So as we get here, and as this concentration of X, all right, which is the 75% solution is added, what do you notice about the proportion of the brine solution? Well, as you do this, you notice that the rate is growing slowly, okay? So it grows, it increases, all right, very slowly. It actually starts to level off, it appears, right? Increase slowly. Now, if you're in pre-calculus or AP calculus or whatever you're taking, all right, you would say as you increase slowly, all right, as X approaches a certain value, we would actually characterize that as a horizontal asymptote. The value that it's approaching is actually the horizontal asymptote. And actually, that's where it brings us to part C. It says, what percent does the concentration of brine appear to approach? Well, this thing where it says the percent, that's referring to the C value, does the concentration of brine appear to approach? Appear to approach actually is referring to the horizontal asymptote. Now, you can look at this graphic and maybe try to figure it out, but as it gets bigger and bigger, we know that we're approaching, all right? That means we're finding a horizontal asymptote, means finding the HA, which is a horizontal asymptote. And I'll write that out for you, those that don't know what it is, but horizontal asymptote, all right, of this rational function, of the rational. Okay, so we'll look over here, and I'm actually going to look to see that. So we look at this, and we look at our equation, and if we find our horizontal asymptote, we compare the numerator and denominator in degree. That's easy of figuring it out, so that's where you might do this. And it appears that growing at the equal rate. So that means if we grow at the equal rates, it's normally going to be the leading coefficients. And so it's approaching, actually, y is approaching 3/4. Or in this case, it's not y, it actually is c. So that means it's approaching 0.75. Okay, 0.75. All right, so that's the proportion that c is approaching, which actually is 75%. Right, 75%. And that kind of makes sense because as you keep on adding more and more of 75% brine, it's eventually probably going to be approaching that value anyway. All right. So that is what we have right here. That's our answer. All right, located right there. That is the horizontal asymptote. All right, for our answer, and you can see that up here. All right, in doing this, and that's where we have the horizontal asymptote, HA. All right, and that helps us answer. All right, well, here's another example of finding domain using horizontal asymptotes and involved with rational functions. So hopefully this helps you out whenever you're given different word problems. Good luck and God bless you.